All right, so we have started recording also. This is a kind of a diagram probably using which you can try to understand a little bit more if you want. I think the diagram may not become bigger. This is what it is. As you can see, UDP server, and there may be many clients. UDP client 1, client 2, like that. There can be many number of clients. So what is happening? How are you actually designing the system programs? The client is first, to begin with, is going to send the packet or the data. Send it to by using the send to system call. So this send to will contain both the data that is to be sent as well as the IP address port number of this particular server. So that over the network, that data will reach this particular machine and the process within that. And this machine naturally, how is that it is going to receive? It should run naturally a system call called receive from. And this receive from is going to contain the parameters so that the incoming data is going to be stored into the parameters, and also the incoming IP address and port number of this machine will also come along with the packet. So this server understands or knows what is the IP address and the port number from where this data is coming. And then it's going to do the required processing or whatever, and ultimately the process the result. The result, whatever would like to is to be communicated to the client, is going to be communicated using send to system call. So as a part of this send to now, again the result that is processed here by the server will be there as a part of that. And then IP address and port number where this result or result must be communicated back, because that has come here while receiving the packet. So the same IP address and port number is going to be there as a part of send to, so that it's going to send to this. And this fellow is going to receive so that he understands, oh, I got the answer from so-and-so server. Wonderful. Like this, any number of clients can actually do that. So same thing, in fact, we have the other day, we have just simply opened our this particular thing, these are the system calls, right? So you can see here, send to system call provides what? SOC FD. You must have already opened the socket, definitely. So the SOC FD will talk indirectly about what is the client IP address and port number. You don't have to specifically bind, because like if from client side, we don't have to bind any specific port. But even if we want to do it, we can, no issue. But as a simple general rule, we don't do it. Any available port is good enough. That's what we see. Only to the server side, the a port number must be known to the client. So you have to bind at the server end. You have to bind the server socket to a known port number, so that what it is, the client can actually connect to. So these are the details, as you can see, right? So this is the socket, and then data that is to be communicated is there in the corresponding address buffer. And how much of the data are you sending? Because you are talking about starting address, and then from that starting address onwards, how many bytes are sent given by this particular line. Are there any flags like, do you want to wait until the packet is sent? So that kind of thing. Many times for normal simple programming, the flags will be 0, right? This parameter is going to be 0. And then what? And then what is the other side of the machine to where this packet must be, this data must be sent? So that's why you have to naturally pass on the address of that. So struct sock addr star 2. So this is the actual IP address and port number. So before calling this send to, we must have initialized the socket address of the server in case you are doing from the client side. Server IP address and port number. With that, we must have already initialized the structure, socket structure, and then its corresponding address must be passed on. And then what? Because they are aware of, whenever you are sending the address, we should also pass on the address length. And this is the corresponding address length. Right? Address length. That's all about send to system call. It's a very simple mechanism, simple system call. Similarly, receive from system call is so same thing. And what is this send to will ultimately return? Send to returns the number of bytes that are actually transferred to the other side of the machine. Normally, if everything is not okay, the send to should return the same value as that of this LEN. Because that's what you ask. You ask the send to send as many number of bytes as this LEN bytes. And in general, send to must return LEN. If there are any errors, it's going to return -1, right? All that kind of stuff. So receive from here, again same thing. First parameter is the socket file descriptor. Using which you are going to receive the incoming data. And then this buffer is the starting address of the buffer where incoming data must be stored. Right? So that's going to be specified. And then we don't know like how many, how much data is to be received. For safety side, you need to pass on what is the maximum data that you want to receive. Right? That is indicated by LEN. Because this is normally like this buffer is likely to be normally an array with some fixed size. So if the incoming data is much bigger than that fixed size, then the program will crash because you have not allocated that much. So one should specify what is your array size so that it doesn't actually disturb beyond that, right? So that's what it is. Buffer followed by the length which indicate the maximum number of bytes that you want to receive. And then the flags as usual, if you want to wait until some data comes is one thing, or if you don't want to wait, you want to see whether anything is there, examine if nothing is there, you want to continue, that kind of things can be controlled by the flags. But many a times it's going to be 0. So receive from naturally will wait until a packet comes from the other side. If nobody is there to send you to anything, then receive from will wait. It's a waiting or blocking system call. And then what? So you have to provide the starting address of the structure where incoming IP address and port number must be stored. So that later if you want to give any reply to that, then this address will be helpful. This socket address will be helpful whenever you want to give any reply back to that. So that's why you are giving the starting address, right? And then what? So you don't know what kind of technology that the other machine is using. So we should also receive the corresponding length of the structure. Because you want to receive the length of the structure, so you have to pass on the address of that, so that the receive from system call can modify that particular value. Whereas here you are not updating, you are only sending to the other side. You are sending to the other side what is the length of the structure here. So that's why you are not passing any address here. Whereas here you are receiving the address and port number of the other side of the machine, what kind of technology it is using, all that is going to be available here. So you are having the starting address, right? So this is about all these things. And then the program might have been there here, but here like he's talking about all other get host by name and that kind of stuff. Those of you who are interested can just go through this, no issue. But let us actually examine a different program together. And we will be writing UDP-based client-server programs. Essentially, the server will receive a string. Server will receive a string, and the client will a string, and it will convert that string into uppercase. What is the server going to do? It's going to convert the string into uppercase and then give a reply back to the client. Back to the client. That's what we are going to actually discuss about. Is it okay? Are you all getting my voice and all? Everything clear?
Yes, sir.
Okay,
Yes,
thank
sir.
you. So we will actually write a simple program, and that's what I have already written that. In fact, I will just simply show it to you, and we can take a look into that particular thing. So first, maybe client-side program is there. Here, we can just examine that, no problem. This is a client-side program, and this is the server-side program. All these programs are simple programs once you understand. There is hardly anything actually. But it requires some knowledge of, reasonably good knowledge of C language. And once you are familiar with C language, then getting familiar with the system calls is not an issue at all. It is not an issue at all. Let us see now the client program, what we have to do it. Right? So naturally, we need to include all the important header files, whatever system calls and library functions we are using, corresponding header files must be included. All of you are familiar with that. And then the int main of all that, so that the command line arguments can be passed if required. We are not actually using any of them, but still it is there as a kind of a habit. We are declaring the main as if it is going to receive the arguments and all that. That's okay. Now, we have to declare naturally a socket file descriptor, and then some kind of result and all that. You're declaring two variables, right? And then the lengths of the structures. Lengths of the structures, to capture that, you are having two variables, LEN server-side structure, CLEN client-side structure, right, to capture that. And then the addresses for both server-side and client-side. So you are having struct sock addr underscore in, internet address, right? So we are now writing all internet-based client-server programs. So server address and client address. And then char followed by buffer of 128, right, to accommodate all the data and all that. That's all as far as the declarations are concerned. No issue. Up to this, I think all of you are familiar with this particular thing. So after this, so you have sock fd equal to socket of a finite sock dgram, comma 0. Right. So this also you are familiar. Socket system call socket of af underscore inet because internet based. Now it is not sock stream, it is sock underscore dgram. Sock stream is for TCP based or connection oriented. Sock underscore dgram is for connectionless or UDP based sockets. So sock underscore dgram. And then the third parameter by and large is going to be 0. So as usual, whenever any system call you execute, if it fails, it returns -1. So you are now verified. If sock FD is less than 0, socket creation is failed. So you say P error off. P error is basically to print the error message. Right? This is a library function by which you can print the error message regarding the errors in system call execution. P error of client socket creation failed. Right? And then you are terminating. Because if you don't have a socket, you can't do anything beyond this. You are terminating the program. If everything is okay now what is to be done? Because when you are sending a packet to the other side or data to the other side, it's the other side IP address and port number must be known. So that's what you are actually filling. Server address dot sin family is AFI, right? Server address dot sin port is 1123. Normally we don't use this constant number, but you have to convert this data in general into network format by using H2NS of 1123. That is a good habit. But for simplicity, I am using 1123 straight away because we are running everything on the same machine. Right? No issue. No issue there as a part of that. Also, the రోజు తెలియదు ఎక్కువ గంట ఉంది. తొందర ఎప్పుడు చేస్తే అప్పుడు అయిపోతాయి. నాకు అర్థమైంది. So is everything okay now? The network is ready? Because I have a little doubt over network today. Are you getting my voice?
Yes, sir.
Okay, thank you. All right. So we are now examining this particular program. Recording also is going on. Okay. All right. So we are basically now initializing the structures here. AFI net and then 1123 is the port number, any number you can just think of. This is the server side, right? We are now actually you are going to about to send your request to the server. So server details you are filling. Remember that. So 1123. And then server address dot sin addr dot s underscore addr equal to. So now you want to connect to the local server, right? 127.0.0.1. But that needs to be converted into integer format. Integer format. So you are calling the inet underscore addr. This is going to convert this string into corresponding integer. That's all what it is. Already we have used this in the TCP based client server program. That's over. And after this, what? The size of the structure must be known. So you are having size of S address, you are placing it into LEN. And then we are just simply putting client is sending some messages for us to understand whether everything is working or not. Right? So client is sending some request. After that, like to be safe side, we are using F flush of std out. This is not required, but even if you keep it, it's okay, kind of it. So F flush of std out, meaning that, so whatever is written by printf, printf normally writes the data in a buffered mode. It doesn't write everything straight away. It writes first into the buffer. And the buffer, whenever it is full, is going to be written onto the actual file or whatever, right, ultimately. So in case you want this to be immediately written, then we use F flush of std out, kind of it, right? And then what is the data that is to be sent? All this we are writing for the client program. So client program, whenever it is running, it is going to ask the user what data you want to send to the server. So that is why you are using fget of buffer comma into the buffer you are reading, right? And then don't read read it into buffer. How many bytes? Not more than the size of the buffer, because already we have declared that. So the user cannot enter more than that, right? And then from where you want to read? You want to read from stdin, standard input. So you're reading the data. What is the data that you want to send to the server? So data is now available in buffer. Now it is to be sent to the other side. So by using the system call called send to. So we have prepared everything. We have prepared the data. We have also prepared the address structure and the corresponding length before initiating the send to. Now we can see send to off. Sock FD. Data is there in the buffer. How much data is to be sent? So the length of the buffer, whatever, plus even the null character also we want to send. Length of the buffer doesn't contain the length or doesn't contain the null character. So to include even the null character, so that also is going to be sent over the network, you are using strlen of buffer plus 1 characters. And then the flags is 0. And where you want to send? You want to send to S address. And its corresponding address must be passed on. But the data type of this structure is different from generic data type. So you have to typecast that. Struct sock addr star. You are typecasting. This already we have done even in connection oriented thing also. Right? So this is done. And then the length of the corresponding structure is there in LEN. That's all. So it's a very simple system call. Once this is successful, it returns the number of bytes that are actually transferred into the variable result. If for some reason it fails, it returns -1. So you are saying if result is less than 0, P error of client socket send to failed. So we know what's going on. Whenever you can't send a request, there is no point in continuing, because naturally server doesn't know what you have sent. So there is no point in waiting for that. So you are terminating the program. So these things are only error handling mechanisms. Once the data is sent, now what? You are only just simply printing a message here. Printf, client sent so many bytes. How many bytes? As many as the value that is there in result. And also you are flushing out. So we know that we have successfully sent. After that, now we have to wait for the reply from the server. Wait for the reply from the server. So how do you wait for it? By making a call on to receive from. But before that, simply fill in CLEN with the size of C address, because your address structure is there in CLEN, right? So normally this is not required, but to be safe side, I am actually putting it. So in general, it's not required in fact. So receive from of what? Socket file descriptor. Where would you like to receive into? It can be either the same buffer or it can be another buffer also, another starting address, right? Only thing is, it requires a mechanism to store the incoming data. So buffer, starting address naturally is going to be there. Again, you specify not more than that. So you specify size of buffer, right? Because you are informing receive from system call that don't fill this buffer not more than the actual declaration, right? You have declared with 128. So you can't receive more than 128 bytes, even if the incoming packet has more than that. So that's why you say buffer followed by size of the buffer. Whereas here you see, it is the strlen of buffer. Here you are sending, this parameter indicates how many bytes you want to send, not the size of the buffer. Whereas here, you, while receiving it, you are specifying the size of the buffer so that you do not receive more than this particular thing. The actual number of bytes received will be there in this result. In this result. Remember that. So buffer comma size of buffer and then 0. And then you want to receive the incoming IP address and port number. So that is there available in C address. Right? That is available in C address. You want to capture that into C address. Because S address now contains the like server address. You don't want to disturb that. Right? You want to have another one so that this is going to be there. So client address is going to be filled. And then because incoming structure length also we should know. So you are passing on the address of the client length. That's all right. It's as simple as this. So if result is less than 0, so something wrong happened. So you say client socket receive from fail. If everything is all right, then we can print the result. Printf client has read this many number of bytes and the actual message that is received is %s. So result comma buffer. And then close. So the client is going to only read one string data and then it sends the string to the server and then receives the uppercase of that particular thing, print it and terminate the program. It's only a one-time job. But if you want this to be kept in a kind of a loop so that it reads a string, send it, receive the uppercase, print it, once again read, send it, receive the uppercase, print. That way also you can always do, right? You want to repeat this service as many times as you wish. It is possible by keeping all these things into a loop starting from this line number 25 onwards, probably. Right? I hope all of you have understood and followed everything without having any trouble. Then the other one is now the server. Right? All of you are there with me?
Yes, sir.
Yes.
Okay. So you are now including the header files, all the header files required for what you call server program, whatever. And then now you are actually writing a small function which will convert a string into uppercase. How do you write that? It's not returning anything, but it is converting, like it's going to receive the starting address of the string. So because we know the starting address, we can manipulate the very data itself. So that's why it returns nothing, so void. And then the name of the function is str upper, because we don't have uppercase conversion as a kind of a library in string library or whatever. We have a uppercase conversion to a character. Individual character can be converted. For that you have a library function. But for a string you don't have. So C language doesn't contain rich set of libraries, right? So whereas other languages yes, very much and all that. So anyhow, so str upper of character star yes. So it's going to receive the starting address of the string that is to be converted. Now what? The string now naturally what? It's going to contain the data, characters and all that until a null character is going to be. So null character is the terminating character. Null value is nothing but 0 actually. So 0 means actually what? False, right? So we can use that particular mechanism to write this very nicely, in fact, by using pointer arithmetic and all that particular thing. Hope you understand it. While star yes. Star yes means what? Yes is a pointer, where star yes means you get the character that is available at that particular location. So if you have reached the what it is that delimiting or terminating character called null value, then star s will contain 0 or the null value, which means that it will fail. So whenever the while condition fails, it will get out of the loop and return finally back to the calling place. But if it contains something other than that, it is a character now. That character needs to be converted. So you go into the loop. So if there is a character, what? You have to update that. So how do you update? Star s is equal to 2 upper of star s. Star s returns what? Returns the character that is available. And to that you are applying 2 upper. This 2 upper is a library function actually, which is available in ctype.h. These are all character type functions. All the library functions that work on individual characters, they are there in a header file called ctype.h. Individual character, not on strings, remember that. So 2 upper is going to take a single character and returns the uppercase of that. So to this 2 upper you can pass anything, even a digit can be passed, any non-alphabet also can be passed, non-lowercase also can be passed, in which case it doesn't change. So anyhow, so 2 upper of this returns the uppercase version, and that is to be stored where? In the same location. So you say star yes here. Star s is equal to this. This I think all of you are familiar with the pointer mechanism, how they work and all that, right? So you are using. So after this what? You have to move on to the next character. Next character's address is available in the next value. So yes plus plus. What is yes? Yes is the address actually. S plus plus means you are going to go on to the next address. So that it takes the next character, next character, next character. After some time, you will reach the null value. That is the time when it will get out of it. So you have converted all of them. Okay, so now the main function, where actual communication and processing is going to be there. Server what? Server is going to receive first the request. It is going to receive the request first, do the uppercase conversion, and then send the uppercase of the string to the client. That's all what it has to do it. So required declarations, you have to do it. So int, sockfd, result and res, anything. And then sock len underscore t, len comma clen. You can also put in fact int here. I think here we have put int maybe. Right, we have put int, this sock len and all that. So you have specific data types also, as all of you are aware of. Basically integers only. Depending on the purpose, they are type def or they are given a different name. For socket lengths and all that, there is a different data type called sock len underscore t. But remember, this is nothing but integer only. Either you can put int here or you can put sock len underscore t. Right? So followed by len comma clen. And then socket structures, you require sock adr in, server address, client address. Character buffer of 128 to receive the data and all that we require. Straight away now, very simple. Right now we are writing the code for server side. Server side means what? We should naturally bind our socket to a known port number so that clients can actually communicate. Any port is not good enough. We want to bind to a known port so that client can send the packet to the known port number. So binding is required in the case of the server. So anyhow now, if socket is less than 0, there is a socket creation problem, so you are terminating. Otherwise what? So now you are filling the server address with appropriate details. So S address dot sin family is A finite. S address dot sin port is whatever number that you are giving, that is the port on which the server is going to listen or is going to receive the packet. So same thing must have been given in the client side also. Remember that. Normally we have to use H2NS. But I am, for the simplicity, I am writing here straight away the number itself. Remember that. So, and then S address dot sin addr dot S underscore this thing equal to, here also you can specify that inet underscore addr, all that, or you can specify in addr any. Is nothing but server would like to receive the request from any of the clients on the network. Any of the clients on the network. This is equivalent to that 127.0.0.1 only. That's okay, no issue as a part of it. Right? So in addr any, which is a constant that is declared in the header files. So and then len equal to size of address. After this now you are going to bind it. Bind of what? Bind of socket FD. And then you are binding the socket to a known port number and address, IP address or whatever. So here you are passing on the address of the structure. And also what is the length of that particular thing. Right? Not the address, remember, because you are not modifying. You are only informing the bind that the length of this structure is so and so. So whenever you are modifying the length also, then you have to pass on the ampersand. Right? So especially when you are receiving asset. Here you are not receiving, you are only binding. So that means essentially when, for example, in the case of the accept system call, in the case of the accept system call, you are receiving the request from the client. At that time, the length must be the corresponding address. Address of that must be passed on. Whereas here, this is okay. Now you are receiving it into RES. If the bind is successful, it returns non-zero, non-negative, right? If bind is failed, -1 is going to be returned. So if RES is less than 0, server socket binding failed. Right? So that, see, essentially when you're writing this kind of so many system calls, if anything fails, the remaining thing is useless. So that's why, like, one should be careful at the end of every system call, take care of the error messages so that you will know like why the program is failed. All right. So once it is bound, now what? It is a server. Server is going to continuously work. Server is going to continuously what? Wait for request from the client, do the required processing, give a reply back to the client. Right? That's all what it is. So to begin with, now you are initializing the client side structure length, CLL equal to size of C address. And then so that that's going to be used in the other things and all that. Right? So now you can see this is the actual code for the server forever. So while one, forever loop. Printf server is waiting. Just for us to understand. Nothing else. Right? And then a flush of STD out. Now what? Server is going to receive the request, right? Whereas in the client side, you have sent first. First send to and then receive from. Whereas here, it is received from and sent to. Right? So this is the kind of the protocol that you are actually using. It is same thing, in fact. Now you already know it. Except that you have to write that code in the reverse order. So receive from socket FD, buffer. And then because you are receiving now, you should receive not more than what? Not more than the size of the buffer. Buffer you have already declared with 128 characters. Buffer of 128. So that's why you are specifying here, don't receive more than 128 bytes of data. That's all what you are actually saying. Buffer comma 128. And then 0 flags. And then incoming IP address port number, ampersand C address. And incoming structure length, ampersand CLA. because you are receiving. So address must be passed. Simple. If you want to find out what is the port number to which your client is bound, you can print it in fact if you want, because that is available in incoming C address. Just for that sake, I am actually printing it. Printer, client port number is %D, C address dot SIN port. SIN port. Because we are not bound there. Client can get any port number. It's okay. Whereas server is bounding to something. But this port number is required so that the server can send the reply back to the client. So we are only printing here just to show you that how things are working and all that. So client port is so and so. Because I don't have a network where another machine is there and all that to test, so that if you want, IP address also can be printed. Because I am running both client and server on the same machine. So IP address, there is no change in that. So that's why it's not required. But otherwise, if you want to know even the IP address of the machine on a network, you can print even that. Because that C address contains IP address of that also. Anyhow, so once this receive from is there, it's going to return the number of bytes received, and result is there. If result is less than 0, something wrong happened. So you are terminating the program by printing another message. Okay? So and then like what? And then server, how many bytes it has read? You are printing. Printf, server read that many number of bytes. And what is the message that it has received? Both. So result comma buffer. After doing that, what? You have to now convert this data that is received into uppercase. So you are calling the str upper of buffer. You are calling this str upper of buffer. So that at the end of the calling, buffer must have the data that is converted into uppercase. Right? And then you are now printing whether everything is doing or not in the server side also. Printf, server upper bytes, and then percentages buffer. So same buffer itself is going to be modified, basically. Now we have the result in the buffer, which is to be now sent back to the client. So how do you do that? By using send to. Client address is there in our C address. So we say send to of sockfd buffer, how many bytes? As many number of bytes as we have received, and that is available in result. And then 0 is the flag, and then what? The address of the client address. And now whenever you are sending, you are not going to send the address. Remember that. You should be careful. You are sending the length of that particular thing. Because you are sending, you are not updating. So you are only informing to send to system call that this address contains this many number of bytes. This is a structure. And these structure lengths vary from network technology to network technology. So again, if result is less than 0, something wrong happened, display the error message. If everything is okay, you display the same thing, like how many bytes that it has actually sent is available in result. So server sent this many number of bytes. Again, closing curly brace, meaning that it's going to go back to the while loop. And again, keep waiting for one more, keep waiting for one more, and so on. Right? It is a very, very simple program. So now we can now verify how it works. What are the names? Datagram upper server, datagram upper client. These are the programs. So if we want, we can in fact like, because we have not modified anything, so we can compile them and then show you how it's going to actually work. How it is actually going to work. Let us see how we can. So just a minute. Hello. What are they? Electrician. ఉన్నాడు సుమతి ఏడ నాయన ఆయన ఎవరు ఎలక్ట్రీషియన్ మాట్లాడుతున్నాడు, ఏమన్నా చెప్పాలా? కిందనే ఉన్నాడంట. చూడు 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 చెప్తాడు, చెప్తుంది సుమతి వస్తుంది. రైట్ అయితే చెప్పు, వస్తున్నాడు. రైట్. So change into the network program folder and into that IP this thing. Are you all there? Everything okay?
Yes, sir.
Because from
Yes,
my
sir.
side there is some problem network, that's why I'm just confirming. Okay. Let's now start the terminal. This is where we can actually verify the files and all those things. These are the things. Now DG and all that, right? If we want, we can compile at your here itself. Compilation is because for me that problem is there, or we can just, already it's compiled. I can show you what we have to do and all that. So this is for the client side. GSS, because C is not working, I mapped it. GSS DG upper client dot C minus O DG upper client. So compile it. So it is compiled. Similarly, server also must be compiled. So this is the server side. GSS DG upser dot C minus O followed by this. So both of them are compiled now. So let me clear the screen. And now you have to run the server. Or by any chance you miss and then you run the client to begin with. So what is going to happen also can be seen. DG upper because this problem is there. Okay. So if you run this program without running the server, you can see here, client is sending. Client sent 2 bytes. How can it send? So probably it is forever like client sent 2 bytes. So what's going on here? So let us see now, like into our program, client is sending, client sent 2 bytes. So let us see the actual program in the client, where and all it has gone. Let us see. Socket creation, no issue, right? So it has gone ahead. And then structure we have filled with 1123 and all that. And after that we have read because fgetus is there. So naturally no issue. You just wait for that and all that. And then send to of all this. So send to, now you are trying to send to this server with a specific port and all that. So client socket send to failed. No, we did not get this somehow. What we have got is this. Client sent how many bytes? 2 bytes. 2 bytes for the reason that one is the new line and the other one is the null character. So 2 bytes it has sent. So it has successfully sent. That is what it is saying. But after that what? After that, if you see, it has to receive from. Because the other, like server is not there, you will never get the corresponding thing. So forever it is waiting there for whatever. But here, instead of placing a 0 here, there is something called message confirm, right? So only then you should like return back. So that kind of things and all can be actually done. If you want to even verify all such kind of things and so on like that. So right now you are not getting any error here. It is forever waiting kind of thing. So let me terminate this particular thing. And then run the like a server and also the other one later, so that right. So this is the one ./dg upper server. Run it in the background, right? Run this in the background. So now it is saying server is waiting because it is a process. Process ID is 5289. You can also see here in the PS. So that program is running. DG up server is running 5289. This is okay. Now you want to run the client. So server naturally is waiting for any client request and all that particular thing, right? Now you run the client, DG upper client. You can see here client is sending. Sending what now? Because it is waiting there, I have to type something. I have to type something in the input, right? So what shall we type? So network program, let us say network program. This much, and then the new line. So if you take a look into all the outputs, what we see here, client port is 39306. Server is printing actually. Server is printing. That client port is 39306. Server has read 21 bytes. So you have actually sent 21 bytes. Network programming, a new line, and then a null character. That means 19 bytes must be there here, and then 2 other extra bytes. Server upper bytes. So it has received this actually, and then a new line, whatever, and converted that into upper. Now client sent 21 bytes. Actually, it is like because these two programs are running in concurrently, so anybody can get. Remember that. So output you are seeing in a different sequence. Client sent 21 bytes. In fact, here client is sending, and then network is this thing. These two lines are from client, and all the remaining things are from the server. But this is again client sent 21 bytes. Client has read 21 bytes. Network programming. Client's server sent 21 bytes. You can see after client sent, like server also is sending, and then server is waiting. Server is again waiting. Is again waiting for that. If you want, you can run the client program once again. Now we can see hello server like this. So now you are getting the hello server related stuff. So this is how you can actually write this thing. Any doubts or any questions at this point of time? Or you have understood everything? Are you following? All of you?
Yes, sir. Yes, sir.
Okay. So in which case, like I think as far as the client server programming is concerned, right, to the extent that all of you actually require, we have covered that. So if you just take a look into the syllabus once again, in Java. Okay. So network IPC, if you just take a starting from here actually, introduction to Unix sockets we have done, IPC over a network, client server model, address formats, Unix domain, internet domain, socket system calls for connection oriented we have done, communication, socket system calls for connectionless we have done in today's class also. Example, client server programs, single server, we have done that. Multiple also, last class we have seen. By using the fork system call, you have created a new process to attend to the client side request, so that the main program will continue accepting the connections, and the child process will attend to the actual servicing of the request. So we have done that already, in fact. And socket options, set sock OPT, get sock OPT, and FCNTL. I think this we can, for the time being, delay that, right? So if we want, we can look into that particular thing also, in fact, by using those message confirm, message wait, that kind of stuff are there. Probably you just take a look into, if possible, on your own by just typing on the internet, set sock OPT, get sock OPT, FCNTL on socket options. Try to understand. If you find any difficulty, we will look into that, right? So those are straightforward cases. Even as a part of our book also it is there into that. So after this, now what we have to do is network programming in Java, right? That part we have to actually do that. So we will continue on the network programming aspect itself, but by using a different language, Java language. In which case you have TCP based socket and UDP based socket. Server programs, all that naturally, Java being object oriented. So we must find appropriate classes. What are the classes that will help us in building network programming using TCP and using UDP kind of thing, right? It is much simpler, in fact, using Java, except that you require Java language. But the other part is simpler, like essentially connection establishment, reading the data, that kind of stuff is much simpler in Java, in fact, compared to C language, because C language sockets were, remember that, like this network programming using Java is basically internet based, remember that. It is not a generic socket. That is the reason why it becomes easy, right? Only internet based socket programming is what you are going to actually study in Java socket programming. But in the case of the C language, those sockets can handle different technologies. Unix domain, internet domain, and even other domains, in fact. You have Apple-based technologies are there, and you have like X-Open kind of technologies are there. It can handle all types of network technologies. That's why it is more generic. That's the reason why you have a generic address and you have the specific addresses. Whereas here in the case of this Java, only internet based. So that's why it becomes much simpler. We'll look into that very easily, in fact. Right now, we don't have any specific book, I think, in our this thing. All of them are C language only. The other one, Java-based thing, I have not shared. So that part, we will look into that, how to actually get that, whatever. I think it should be possible. Like there are different books. One is maybe Herbert Schild, complete reference kind of Java is there, and some other good books we should be able to find them. I think Bruce Eckel book also must be available as a part of that. This part we can close it. This also we can close. Just let me introduce you to a simple basics so that you come prepared, and next time we can run the class a little quicker, right? So I'm just typing, as you can see, Java network program. Life is so simple these days, right? You don't require a teacher really. So from 4th edition book, O'Reilly, actually maybe it's available free of cost. It's wonderful. Otherwise, like we can go for some other book. O'Reilly books normally, like they are available free of cost, in fact, for about 1 month kind of it. Start your free trial, like this is going to give. We can go into that particular mode also, in fact. so that you need to give your details and all that. So I think this part you handle that. I will just go into other mode. But it is a good source, in fact, O'Reilly. I have used earlier. Lot many good books are available, and all of them you can use freely there using search-based mechanisms and all that. Java T point and then all that and so on. Tutorials point also is there. SlideShare, you have one book. I think SlideShare maybe you may find one book there probably. Let us look at that. '63. That means these are all slides actually, not the book itself, not the book. Instead of that, the best thing is probably look for a PDF book rather than all this kind of thing, right? I will show you how you can actually just simply give extension ext or file type. Either way you can actually use ext:PDF. Now you will find all the PDF books related stuff. Maybe the very first book is this. Let me download this and show you what is possible. If you want the link to be available, I'm sharing with you so that so this is a link. I don't know the quality of the book and all that. I have not seen that, but maybe we depend on the Google search because it has given this as the first entry. So this is again O'Reilly only, Java network programming, developing all that he's talking about. O'Reilly book only at all. So let me download this. 500 pages it is there, like where it is going to store into desktop. But instead of that, network programming and then books. Here I am going to save it. Okay, so this is already saved. Now we can go into this and then go into books. And then what? What is the book title? Java Network Program. Java Network Program. This is the one. Wonderful. You don't have to read the entire book. It may address many things there and all that. Basic networking concepts is going into URL, internet addresses, sockets for client, sockets for server. These are the two things. 8th chapter and 9th chapter is what we'll have to look into. Sockets for clients, sockets for server. These are the two chapters. Let us go there and then see what is going to be available. Using sockets, right, wonderful. So this we can, this thing, and then try to increase the size of this. 200 is a little big or what? No issue. For this, naturally, you must install Java to begin with. And once you install, everything is available. Right. Where are we? We are in the sixth line. Like it is somehow not working in that particular sense. So then it has come. Okay, now it is somewhat better. Java network programming. No, it is still only second line only, I think. It is still in the second line. Okay, so he's not, these links are not working. So what we have to do is, somehow he is not giving even the page number. Then we'll search, and then go there. Search and then go there. Chapter 8. Chapter 8 we'll search. I think that way we should be able to go straight into that. Chapter 8. I can't type C there, but let us see. Chapter 8. I see. This is something, this one. Now you'll have to go into this one. Only these two. Oh, slowly it's like it's taking time somehow. IT book info and all that. 262, 261, all that. URL connections, 8th chapter. 8th chapter is what we require, right? Let us see. Sockets for clients, right? 261 is correct now. Somehow it is slow, running slow a little bit. Okay, so this is right now 271, wonderful. New socket, right? You can see here how simple it is to create a socket. Naturally, because this is object-oriented programming, how do you create sockets? By just simply saying new followed by, there is a class name called socket class. There is a class called socket in Java. Just simply say socket of. You have to specify then what is the IP address or the domain name here he is using, and then the port number. Right? This is the IP address of the server with which you would like to connect to. Because this is a client-side socket. We are creating a client-side socket. There are two types of sockets in Java language. Client-side socket and the other one is server-side socket. So for both of them, you have two different what you call classes. This socket is used for, this is a client-side socket. To create a, what it is, the server-side socket, you have a class called server socket. You have a class called server socket, right? So this is how it is now. So new socket of, what is the server IP address or domain name, comma, server IP address. And this is returning a socket now. And that can be stored into one variable, right? So now this can be used for like what it is, like communication purpose. This socket can be used for communication purpose. Naturally, you should be good at now I/O handling, input output, by using streams and all those things and all that, right? So now as you can see, socket dot, after doing this socket, you say socket dot get output stream. Socket dot get output stream returns an output stream object. Returns an output stream object. So that anything you write onto this output stream is going to be delivered to the server. Is going to be delivered to the server. That's what he is going to likely to do that. As you can see here, new output stream writer of. If you want a writer object, you are going for writer here. Otherwise, you can as well use this out itself and then write. but instead he is going for writer objects, like a better, like reader writers. Java begin with input stream and output stream classes. That is the old style. Later they have like made lot of changes and like created the reader writer classes. You can use old style also, or you can use the new style where a lot of other additional functionality is there and all. So by using the socket system, socket object, you are trying to get an output stream object by using socket.getOutputStream. Then anything that you write onto this is written onto the socket, meaning that it is delivered to this server and port number. Now he is not stopping there, he is creating a writer object. So writer equal to new output stream writer of output stream object. And then what kind of data you are going to send? UTF-8. But you can as well say simply out also. After this, as you can see, now he is writing onto this thing, writer.write off, whatever message you want to write. And in case you want to flush it, you can say writer.flush, like this, right? So we are now taking a look into the sample actually. We will again come back, but the objective of this is to make you to start reading and come to the class with small reading so that you can understand better. You can download the same book and then we can work on that. So similarly, if you want to read something from the socket, you require an input stream, right? So you can see here socket.getInputStream, so that you are going to have input channel also, right? And then now, like instead of using the input stream, he is using the reader class, right? Buffered reader. Reader equal to new buffered reader of new input stream reader of in comma UTF-8. So this is a complete thing in order to create a reader object so that you can read the data in a better manner. That's all what it is. Now he is saying for string line equal to reader.read line, like, so what is going on, like, so anyhow, so he's reading first line into this, and then like as long as the line is not containing a dot or whatever, and then all this, he's actually talking about lot of things, whatever. So when you look at a dot or whatever you are trying to terminate and all that, ultimately network-based English to Latin translator, some kind of a program he is actually writing. So dictionary client kind of thing. Import java.io.star, import java.net star. This java.net is the actual package that contains all the classes relevant for network programming. Java.io is a package that contains all classes meant for input-output operations on the files. Right? Ultimately. So this is the actual program there. Try to go through that particular thing and see what's going on, right? So definitely all of you should refresh your Java language basics and then start reading these things. So this is a client side, whatever he is actually trying to do that. Similarly, server side, somewhere we have to actually start. This entire chapter is clients only, sockets for clients, he said. So that's why all this is there. So we can just take a look into the similarly server side also, just a little bit, so that you are actually given the basics to proceed further. 9th chapter we'll have to go into. Next chapter contains like that. So different authors present different ways. So it all depends. This book is a highly professional one, definitely it seems, because a lot of details are there. You don't require all this, but still, like whatever is relevant, we are going to capture that and then move on. Lot of programs are there, in fact. Like in case you want to, have a simpler one also, you can. Like Directly we can get client and server program on those tutorial points and all that. Matter of 10 pages kind of thing. You are going to get it. But a lot of explanation here. It is a textbook. So naturally, it has a lot more than what you get from the other side. Now you can see here, I just mentioned, there is a different socket called server socket, using which you can create a server-side sockets. That's what is the server-side socket mean? Server-side socket must bind the port to a known port. Client can have any port, no issue. So that the clients can connect to. So that's why server socket is a different mechanism. Now you can see here as simple as this. How do you create a server socket? New server socket of port number. This 13 is a port number. You can give any port number. Many a times you have to give the port numbers. For normal program, port numbers will always be more than 1024. All the standard applications like HTTP, FTP, Telnet, or login, that kind of standard services that servers provide, they are going to use less than 1024 port numbers. Less than that particular number 1024. Whereas you should not give 13 here. Like probably he's using 13 to know the time or whatever, that kind of stuff. Anyhow, so this logic is new server socket of port number. Simply. Over. Socket is created. You are not filling all those structures, that, this, and so on like that. That's what I said. Because this is only meant for IP-based programs. So that's why all those things are not there. So after that, now the server is ready. It can accept the what? Request by using server.accept. What is going to be returned by server.accept? It returns a complete connection socket, right? This socket, what you have, server socket, is only useful for receiving the request from the clients. But it cannot serve the communication purpose. That's why server.accept. You can only accept the new connections. But this is going to return a socket. Remember that. No, general socket. What do you mean by that? This socket only is useful for communication purpose. Server socket objects are not useful for communication purpose. They are only useful for receiving the request from the clients. Right? So that you have to understand. And once you get this connection socket, now you can do all the other things. Whatever you have done in the client side, because this is connection is a socket object. That means you can use connection dot get output stream, connection dot get input stream, right? And then actually writing and reading, all that kind of stuff is possible. You can see here connection dot get output stream. And the new output stream writer of writer comma ASCII, whatever, right? Because this fellow is actually implementing time server, date time server. So that's why he's doing that kind of stuff. Right? So that's why, as you can see, after creating this, there is a kind of a forever loop, while true. And then keep doing whatever is required there and all that particular thing. Here also you have TCP based and UDP based. But this server and server socket, these two are TCP based kind of things. For UDP based, you have other classes that we are going to study them later, right? I think this much is good enough for you to begin with. Either you can use this book or use your maybe simple Google search and go through like a tutorials point, or maybe W3 schools if it contains, or any of the standard things which you feel that you can understand and go ahead. But in the next class, we will start with examples and all those things. So for today then, I will just close the session. So unless you have any questions, I think right? So let me, the link also is shared. You can make use of it, whatever is there. And now I am slowly winding up. Stop presenting. And then recording must be stopped.